Okay, Assalamualaikum and a very good day to all. Okay, so right now we are going to proceed for the next chapter, which is chapter 9, mechanics. Okay, so here in this chapter, we have two parts, which is theory and also application. So for the theory, you need to make sure that you fully understand, because if you have trouble with the theory, it's going to be harder for you to understand the applications. Okay, so this one you already learned in SPM, and I think you already expert because you already learned in calculus too. So but I'm going to recall everything back, and I'm going to present to you the different questions when it comes to the theory. Okay, so right now we only cover we are going to cover only 1, 2 and 3. Yes, okay, so okay, this is going to be the part 1 and the rest are going to be the part 2. Okay, so here today we are going only for the part 1, and after this I'm going to do the video for the part 2. Okay, let's proceed. Okay, so what does it mean by mechanics? Okay, so based on your knowledge itself, mechanics is something that actually moving. Yeah, mechanics is mechanics. Okay, for the mechanics itself, we can actually say that it's something that actually are moving. Okay, so that's why we separate it into two, which is static and also dynamic. Okay, so here you need to understand the Newton's law. Okay, so mechanics for static and dynamic, we only learn for engineering, we only learn about static. So for dynamic, you are going to learn in physics 1. Okay, so you need to understand that when it comes to this, we have Newton first law, we have Newton second law, and we have and then we have Newton third law. Okay, let's recall everything back because it's going to be related to each other. Okay, so when it comes Newton's first law, Newton first law state that, Newton's first law, make sure that you didn't give only inertia. Okay, what does it mean by inertia? Okay, so Newton first law state that object at rest will stay at rest. Okay, and then object moving will moving with what? With constant velocity unless acted by unbalanced force. Okay, so means that if you didn't have any net force, we have a force. By example, if you have you didn't have your net force not equal to 0. Your net force not equals to 0. What happened is this net force going to cause object that will not stay at rest, and will cause object moving with the acceleration. So means that without the net, example, if you get net force equals to 0, what happens is moving with a constant velocity, and object will stay at rest, will stay at rest. So you need to understand that when it comes to the force is going to change the magnitude and also direction. So when you have force, these two going to be changed. So without force means that there's no magnitude, there's no direction. That's the reason why there will be no acceleration. So how about Newton's second law? Newton's second law is basically related to the Newton first law. Newton's second law. Newton's second law state that, if you just take F equals to ma, is going to be very simple, plus people not going to understand. So make sure that you can give me a definition instead of you give me a formula. Newton's second law state that acceleration is directly proportional to what? to net force apply and inversely proportional to the mass. For this one, you only get 1 mark. Another mark is going to be given if you state the direction of acceleration, acceleration, oh my god, sorry, acceleration, Allah, acceleration, follow the direction of net force apply. Sorry for the bad handwriting. It's very hard for me to write on this thing. Okay. So means that, as you can see, that acceleration is a vector. So means that the direction is going to be follow the net force apply. Okay. So means that when you have net force, definitely you are going to have acceleration, because you need to understand that force change the magnitude. So basically what happened is when they have a change in velocity, based on the name itself, change of velocity will be equivalent to acceleration. Okay. This is Newton's second law. How about Newton's third law? Okay. Newton's third law. Okay. We're going to this thing. Okay. Newton's third law. Okay. So this one, okay, if you just state reaction, action, definitely people not going to be understand. Okay. So, okay, this thing basically going to be occurs mostly in the real life. Okay. So Newton's law is about, if we have, okay, when first object apply force to the second object, or we can actually exert force to the second object, second object will exert with the same magnitude of force but different direction. Okay, that's why we call it action and reaction. Okay, example, if you sit on the chair, so chair going to apply force to you, you are going to apply force to the chair with the same magnitude and different direction. That's what we call as a Newton's third law. Okay, so basically what happened here is we are going to in mechanics we are going to use the Newton's first law, because means that we are going for the static instead of dynamic, and then the force that we are going to draw is basically Newton's third law. Okay, so this one are not going to be used now, is going to be in physics 1. Okay, something that actually moving. Okay, understand? Okay, let's proceed to the next one. Then third law. Okay, so before I proceed with the calculations of vector, you need to make sure that you can differentiate between scalar and vector. Okay, so basically scalar is have a magnitude but without direction, and vector have both direction and magnitude. Okay. So vector like force, acceleration, velocity, displacement. Okay, what about kinetic energy? Any kind of energy we consider as a vector or scalar? Okay, so word energy, kinetic energy or potential energy, we consider as scalar, only have a magnitude but without direction. Okay, so please don't be okay, please make sure that you understand that word done is not vector, we only give it a scalar. So when it comes to vector, when you know force is a vector, That's why you need to find a magnitude and direction. So our calculation is going to involve both magnitude and direction. Okay? Okay, so how to detect whether the physical quantity itself is a vector or scalar? Okay, so mostly in your textbook they are going to represent it by they're going to put like this, and then they're going to put arrow above the A. Okay, this one represent vector. Or they're going to put like A and then caps. Caps also represent vector. Or another way they can actually do is they are going to like make it bold. Like that. Okay, so these three style is basically represent vector. Okay, so if you happen to see this symbol, is basically represent vector. Okay, this arrow, this is not like the directions of the arrow, but basically is to represent a vector. Okay, so we are going to focus on the vector instead of scalar. So we need to find a magnitude and direction. Okay, so what is the steps that you need to do to find a magnitude and direction? Okay, so let's proceed to the next one. Okay, before we proceed with the calculations of the vector, we need to understand that we have three types of system of forces. This one you need to make sure that you know the definitions of collinear, coplanar, and concurrent. Okay, because you are going to see all these terms in applications of mechanics. Okay, it's very easy when it comes to the collinear. Okay, collinear means that all forces acting on the same line, like this. Okay, so if you happen to see something like this, you have one forces F1, and then you have one forces F2. This one also we consider as a collinear. Okay, got it? Okay, because acting on the same line. Okay, when it comes to the coplanar, based on the name itself, planar means that plane. Planar means plane. So means that all forces lie in a single plane. Okay, if you say our forces are parallel to each other, this is not that correct. Basically, coplanar means all forces lie in the same plane. Either is in X plane or Y plane or Z plane. Okay, for example, all the forces like this one we call as a coplanar. Okay, means that acting or not means that lie in the single plane, which is plane is going to be Z. Okay, got it? Okay. Okay, so for the concurrent, okay, concurrent means that force comes and end on the same point, or you can actually that forces pass through the same point in space. So example, you have like this is Y axis, this is S axis. Sorry, I draw it back. X and Y. Example, you have like one point come from here. This one we also call as a concurrent, means that come from the same point or end up in the same point. So example, you like have here, we have one forces F1, F2, and F3. This is also we call as a concurrent. Okay, so I'm going to give you this question mostly for definitions, or maybe in MCQ questions where I need you to detect whether it's have a collinear, coplanar, or concurrent. So it can be non-collinear. It means that not acting on the same line. Non-coplanar means that not acting on the same plane. Non-concurrent, it means that not come from the same point in space. Okay, understand? Okay, good. Let's proceed to the next one. Okay, so in front of you, you can actually see that this is like one of the example questions that I'm going to ask you. Okay, so for this one, okay, coplanar, concurrent. Planar means come from the same plane, and concurrent come from the same point. So for this one, you cannot see which plane there as y or z, but basically this is the plane. That's why it becomes coplanar and come from the same point, concurrent. Okay. Okay. Coplanar non-concurrent, it means that come from the same plane but not come from the same point. So means that this one is your plane. Okay, you can see that all the forces come from the same all the forces come from the same point. Okay. Sorry, all the force come from the same plane but not come from the same point. Okay, this is a different point. Okay. This one, non-coplanar, concurrent, means that not come in the same plane, but basically come from the same point. So yes, correct, come from the same point. And this one is basically can be X, it can be Y. That's the reason why they state that non-coplanar. Okay. And this one, as you can see, that basically non-coplanar, non-concurrent. Not come from the same point, not come from the same plane. Okay. Understand? How to differentiate coplanar, collinear, and concurrent. Okay. Okay, this one I already mentioned before, the definitions of the Newton's law, because Newton's law is basically closely relate to the mechanics. So because we are going to draw some forces, which is the reaction force or the action force. Okay, so that's the reason why here is very important. Okay. Okay, so let's start with the calculations of the vector. Okay, forces, as you can see, is a vector. That's the reason why we need to find a vector, magnitude, and direction. Okay, so this is the step, but this step is not complete yet. Okay, so I'm going to show to you how, okay, the simple example and the steps that you need to have in your calculations. Okay, but before that, we need to understand cos and sine first, because maybe there are some of you didn't understand why it becomes cos, sometimes it becomes sine, so it depends on the angle itself. So I'm going to show it to you. Okay. So example, if I have like one diagram, okay, like this, oh my god, okay, I have one diagram, and I have force F1 here with the value of 2800 Newton. So please take note, it can be Newton, it can be pound, it can be pound force. It depends on the unit that I give it to you. Please don't change the unit to SI. Just use the unit that the questions mentioned. If I need you to change the unit, then I'm going to like state, okay, please make sure that you give your answer in SI unit, something like that. Okay, and then the angle here should be like 48 degree. Okay, and then you have this one, another force F2 with 5000 Newton, and the angle going to be 25 degree. And the question asks you to find the questions ask you to find the resultant. Okay, when the question asks you to find the resultant, it's basically asks you to find the magnitude and direction. Okay, so what does it mean? Okay, example. Cow. Okay, example. Okay, actually, this is cow. Okay, this is cow. Haha. Okay, and then there's someone actually pulls you. Maybe we can actually say Ashraf. Ashraf pulls you with some angle and some forces. And then we have English pulls you in this direction with some angle and some forces. And then maybe there's someone else actually pulls you, maybe Ida, okay, with some angle and some forces. So means that at the end, which which direction that cow is going to be pulled. Here, 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 or here. That's the reason why we need to find a magnitude and direction. Means that when cow, actually example lah, cow, at the end, cow going to be pulled at this direction. Example. So means that here is a magnitude and here is your direction. That is resultant. Okay, understand? Okay, simple, right? Okay. Okay, let's proceed to the calculation. Okay, for a second, I'm going to draw it again. Okay, so here we have 5,000 Newton. This is F2. And then we have 25 degree. Oh, sorry, drawing is so bad. Okay, wait for a second. Okay, that here is 5,000 Newton, 25 degree. And then here we have 800 Newton with 48 degree, right? Okay, so let's proceed with the calculations. Okay, first thing first, when you come to this, you need to resolve. Resolve means that you need to resolve these forces into X and Y. So how to resolve? The resultant here, not resultant, the resultant, okay, resultant 1, resultant F1 need to be in between X component and Y component. Okay, the resultant here need to be in between X component and Y component, like sandwich. Okay, so that's the reason why you can actually see that my forces in S going to be in this direction and in this direction. For what? F1S and F1Y. Okay, so how about the second one? Oh no, this is F2, right? F2. Okay, so how about the second one? So here is basically here. So it means that it should be in between the forces. So the force is going to be which direction? It's going to be in this direction, F1S and F1Y. Okay, please take note, when you get this question, it's better, and I encourage students to draw the resolve force. Why? Because it's going to affect your calculations, especially direction. Students tend to do a careless mistake where they actually forgot to put negative and positive. Okay, so please draw the resolve force. F2, F2Y, F2S, F2Y, F1S, F1Y. Okay? Okay. So how to detect the sine and cos? Sine and cos. Okay. Okay, so for the F1, okay, before that, I'm going to recall everything back for you guys first. Okay, so example, if you have forces, you have angle here, means that your F1 going to be F1 cos theta, this one going to be F1 sine theta. Why? It's not basically memorized, it's based on the calculation where cos theta is what? Soh katwa adjacent over hypotenuse. So here, where is adjacent? This part, which is X component. Okay, I put it as F1X. Okay, what is your hypotenuse? And this one. Hypotenuse is your resultant F1. Okay, this one it become F1. So your answer going to be F1S is F1 cos theta. Make sure that you correctly write F1 is resultant and this is the angle. Then you get the components. Okay, I repeat, F1 is your resultant times with your angle, you get the component. This is component X component. Okay, for the Y component is going to be okay, so sine theta, soh katwa sine opposite over hypotenuse. So your opposite here is what? Y component, F1Y, and hypotenuse is what? Resultant. That's the reason why you are going to get F1Y, F1 sine theta. The same thing here. Please don't do a careless mistake when you write something. F1 is your resultant. Multiply with your angle, then you get the y component. Okay? Okay. What if I change a little bit where I put angle in different place? Okay? Example, if I put angle in different place, like here. So this one are going to be F1 sine theta. This one are going to be F1 cos theta. How come it's changed? Because your opposite and your adjacent already changed. Okay? Because now your adjacent is this, your opposite is this. Okay? So when you put cos theta, it become adjacent over hypotenuse. So adjacent right now is what? F1y. F1y. And hypotenuse is what? F1, the resultant. There's a reason why you are going to get F1y is F1 cos theta. Okay? And then for sine theta, opposite over hypotenuse, opposite is this one. Okay? Hypotenuse is this one, your F1. There's a reason why it become, this is opposite, hypotenuse is F1. That's why your F1 going to be F1. F1y, F1s is F1 sine theta. Okay, so even though it looks easy, but students tend to do a careless mistake. So for the students, okay, so make sure that, okay, so angle here, okay, I need to remind again, angle here and angle here is the same thing. Example, if I give you 60 degree, so it's going to be F1 cos 60, and this one also F1 sine 60. Okay. Example, if you didn't want to use the 60 degree, you can actually find here, which is 30 degree. So it become what? It become here, which is the F1s going to be F1 cos 30 degree, and F1y going to be sine 30 degree. Okay, so for the students who tend to do a careless mistake, I'm encouraged you to find the x component here. But if you are actually expert, you are okay with that, you can actually use x and y component. You can use angle touch x or angle touch y. Okay, if I state angle touch x, it means that okay, angle touch x, it means that this one. 30 degree means angle touch x. 60 degree means angle touch y. Okay, that's the, okay. So please make sure that you don't do a careless mistake. Okay, this is like simple, but this is the things that I need to remind students every batch. Okay, good. Let's proceed with the calculation. Okay. Yeah. Okay. So I'm going to draw it again. Okay. Okay. So alamak. Okay. Yeah. So this is 25 degree. This is F2, which is 5,000 Newton. Okay, and then we draw another one, which is 48 degree. F1, this is 4,800 Newton. Okay, please take note. The questions not only give you a force, it can be displacement, it can be velocity, because all the things that have a vector, you need to find a magnitude and direction. Okay, just follow the units. If I give you Newton, put a Newton. If I give you meter per seconds, you put a meter per seconds. Okay, please follow the units that give in your questions. Okay, let's proceed. Okay, so now we are going to find the resolved component for F2, F2x, and F2y. Okay, F2x and F2y. Okay, and then we are going to also find the resolved component for F1x and F1y. Okay. Okay. So is going to be, okay, I'm going to write it one by one. F1S is what? For 800, the resultant multiplied with the component S. Okay, angle touch S component S plane. So this one going to be cos 48 degree. You give your answer in 3 or 4 significant figure. Okay, so it's going to be 800 cos 48. You are going to get 3212 Newton. Put the units over there. Okay, and then you find the F1Y, which is this one, for 800 sine 48 degree. This one going to be for 800 sine 48 degree. You are again going to get 3567 Newton. Make sure you give your answer in 3 or 4 significant figure and then put the units over there. Okay, so this is the tricky part. Okay, so when it comes to the vector, you need to understand that they have a direction. So here, okay, directions. Okay, you can see that F1S is in positive S. Okay, so means that here you are going to get, this is positive S, this is negative, this is, positive X, this is negative X, this is positive Y, and this is negative Y. So you need to put the negative and positive in your calculation. Okay, so means that here the X component is in positive, so means that it's going to be positive. You don't have to put a positive over there, just I want to show you. Okay, so for this one F1Y, as you can see that is downward, so that's why I'm going to put negative here. Okay, so please be extra careful, because one negative going to affect the whole marks. Okay, it's going to change the whole calculation, so be extra careful. So put negative over there because it's force acting downward. Okay, next proceed with the F2. Okay, so F2 going to be F2X. Okay, please take note the angle 25 degree here touch Y axis, so it's going to change your cos and sine. So F2X going to be 5000 sine 25 degree. Or if you don't want to use 25 degree because it's touch Y axis, you can actually use 65 degree. So it's going to be what? 5000 cos 65. Both are going to give you the same answer. So choose which one that actually safe. Okay, it's not okay, not choose something that easy, choose something that's safe for you. Okay, so what you're going to get, 5005. Okay, you are going to get 2113 Newton. Okay, so double check the directions. Direction is here, positive. That's why we put positive over here. You don't have to put positive over there. I just want to show it to you. Okay, so the F2Y, next is F2Y. F2Y is 5000 cos 25 degree, which is basically same if you put 5000 sine 65 degree. They are going to give you the same answer. Okay, so 5000 cos 25, you are going to get 4532 Newton. Okay, double check. Okay, because Y is in upward positive, that's why it's going to be positive. Okay, so next step is you find the net force in X, you find the net force in Y. Okay, so it's going to be where? Cos 48. Okay. So the next one is you need to find the force in net force in S, net force in Y. So here the next step is net force in S. Means that you only focus on S, which is this one and this one. Okay. So means that is going to be Net force means all going to be positive, but if your answer have a negative, then you need to put a negative over there, okay? So it become 3, 2, 1, 2 plus 2, 1, 1, 3. Positive and positive. That's the reason why I make it positive. So you're going to get 3, 2, 1, 2 plus 3, 2, 1, 2. 3, 2, 1, 2 plus 2, 1, 1, 3. So the answer is 5, 3, 5, 3 to 5. To 5 Newton. Okay. Okay, so for the X, this is net force in X. Net force in Y, it means that you need to find only Y component. Focus only Y component. Oh, sorry. So this one going to be here and this one. Okay, so please be extra careful. You have negative over here, so put negative over there. So it become negative 3, 5, 6, 7 plus 4, 5, 3, 2. So what you're going to get is 6, 7, 3, 5, 6, 7 plus 4, 5, 3, 2. So you're going to get 965 Newton. Okay. You are not done yet. Okay, you need to find the magnitude. Okay, so this is you only find the component. You find the net component. You didn't find the magnitude. Okay, so the next step is going to be you need to find the net magnitude. Okay, so it's going to be magnitude always be positive. Okay, so magnitude force. Okay, or you can actually use R. R means that resultant. Okay. Resultant. Okay, so or I put R lah. Okay, R going to be square root, which means that net force S square plus net force Fy square. Why the formula going to be like this? Okay, before this, when you learn in maths, okay, if example you want to find the resultant here, okay, resultant here, you need to like, okay, example like triangle, right? Okay, like this, right? So this is A, B, and C. So so if you want to find C, so it's going to be A square plus B square equivalent to C square. So if you want to find C, it's going to be A square plus B square, square everything. Sama macam ni. Okay, because right now you're going to find the resultant. Resultant is C. That's the reason why we get this formula. Okay, got it? Good job. Okay, so the answer for this one, you find, can always be positive. It cannot be negative, okay? Resultant always be positive. Okay, so you put over there 5325 square plus 965 square. So 5325 square plus 965 square. 5325 square plus 965 square, square root everything, then supposedly you are going to get 5412 Newton. Okay, this is the magnitude. And how about directions? Means that you are not done yet. Okay, so for you to find the directions, you can actually use cos, sine, or tangent. Okay, means that right now you need to find what is the angle for the resultant. Okay, this is the resultant angle. So the angle, okay, it's better for you to use tangent theta, because tangent theta means that opposite over adjacent. So katwa, which is opposite here, and this is adjacent. That's the reason why I encourage you to use tangent. But you can use sine or cos. It's okay. You are going to get the same angle. Okay, so tangent theta, opposite of adjacent. Opposite is Fy, and adjacent is Fx. Okay, this is sum of Fy and this is sum of Fx. Okay, so it's going to be sum of Fy over sum of Fx. So you're going to get 965 over 5325. So theta is, you need to shift time. Okay, so 965 divided by 5325, shift time, you are going to get 10.27 degree. Measure the units. This one, units. 10.7 degree. Not done yet. Which direction? South, east, north, west, southeast, southwest. Okay, so if you give like south, northeast or northwest, something like that, okay, but I think maybe you are going to like do a careless mistake where you actually wrongly give your answer. So it's better for you to draw. So drawing, this is y and this is s. Wait, I make it alamak. Okay, alamak, ayo. Okay, tak apa. Okay, so why is it moving? Okay, so means that for the drawing, you draw y and x. Okay, how to draw? You are going to look at your result, your net x and net y, which is net x, net y here, and your net s here. Okay, this one you're going to get, you get positive, right? This one also you get positive. So positive x, positive y. So which direction? Your resultant here. Yes, this, okay, I repeat, you are going to look at your resultant, your net y and net x, positive and positive. So that's why you get positive x, positive y. So here is going to be 10.27 degree. And your magnitude, which one? This one. So write your magnitude, 542 Newton. Okay, so you are going to get full mark, 8 or 9 marks. Okay, something like that. Okay, understand? Okay, good. Okay, so try to do the next questions. I think the next question, okay, this one is very simple. Like the question asks you to find the s and y component for 6.550 power of 2 pound. Okay, so means that is going to be some, f s is f1 cos theta. Why become cos? Because angle in touch as is. Okay, so it's going to be 6.50 power of 2. Cos theta is 2 vertical to 5. 2 vertical, let's look at 2 vertical, 5 horizontal. So this is 5, this is 2. Find the angle here. Okay, so it's become what? Tangent theta lah. Okay, tangent theta, right? So your angle is 21.80. Okay, so it's going to be cos 21.80. Give your answer. 6.50.2 times cos 21.80. Okay, 603.5. Unit is pound, not Newton. Okay, please be extra careful. Okay, and then Fy is become 6.50 power of 2 sine 21.80. So we are going to get 6.50 power of 2 sine 21.80. 241.4 pound. Okay, double check. So positive, fx positive or fs negative. Okay, moving in positive x and y is moving in positive y. So that's why you're going to get positive and positive. Okay, easy, right? Because this only have one forces. That's why you don't have to find the magnitude and directions. Okay. Okay, next. These questions. Okay, please do this question. Okay, and then this is the answer. Okay, so make sure that you show your answer, you draw which the resultant going to be in which direction. Okay, so I can ask you angle, or I can actually put like this. So if I put like this, you find the angle, which means that here angle, I think you remember the z method in maths. I didn't know the name, the real name, so like zigzag. So angle going to be here, right? So 42 answer. So this one going to be 63.5 for 3 degree. Okay, so the same thing, the same method that I mentioned before, you need to find the F1 as F1y. So the resultant going to be, oh my god, okay, so the resolved force for the F1 going to be in this direction and this in direction, which is this is F1 as F1y. Please take note, the resultant should be, no, the resultant for F1 should be in between the angle. Okay, so the F2, is there any, okay, F2, as you can see that is only lie in the x-plane. So what is the value for F2y? F2y going to be 0. So F2s is going to be 58.0 cos 0, and F2y going to be 58.0 sine 0. Okay, why 0? Okay, in physics, okay, I know that maybe there are some means, can we use the maths? Yes, but it's going to be a little bit confusing, so it's better for you to stick with the physics style. Okay, so we actually assume that this is 0 degree, this is negative, this is, wait, I don't know. Okay, this is negative 0 degree, this is 90 degree, this is negative 90 degree. Okay, so yeah, that's the reason why cos 0 and sine 0. So sine 0 definitely 0 lah. Okay, sine 0. Okay, so that's why is only have a F2x instead of F2y. Okay, you don't have to write cos 0 or sine 0 if you already know that this one definitely in x component. Okay, and this one this one in x component means that the only thing that exists force is F2x. F2y going to be 0. Okay, okay, so how about F3? F3 here, F3s, and here F3y. So be extra careful with the negative and positive, because definitely this one going to give your answer in negative, and this one also give your answer in negative. Okay, okay, fine, and try, and if you have any problem, feel free to ask. Okay, okay, so this is one of the questions that I'm going to ask, or maybe another question that I'm going to ask you is, you need to find a result, you need to find a missing forces. Okay, okay, wait, okay, let's proceed to the next one. Okay, so example like this question is quite different from the previous question that you do. The previous one, you need to find the resultant. Okay, however, for this question, the resultant already be given to you. However, the forces, the F1 and F2, they doesn't give you the magnitude. Okay, so you need to find it. Okay, okay, so for this kind of question, it's basically easy, but students tend to do a careless mistake also, so please don't be panicked when it comes to this kind of questions. Okay, okay, so first thing first, I'm going to find the angle here first. Okay, because angle for the F1, angle here going to be 28 plus 45, 90 minus answer is going to be 17 degree. Okay, 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 so I'm going to use the R here, I'm going to the angle 28 degree. For the F2, I'm going to use angle 20 degree. So right now, the question asks you to find the magnitude of F1 and F2. Okay, not the directions, only magnitude. Okay, so for you to do these questions, I'm going to show you the steps. Okay, so it's you can actually okay, I'm going to show you step by step, but I'm going to state which steps that you can actually skip once you already understands how to do this kind of questions. Okay, so first thing first, you can actually draw a table. Okay, draw a table. Okay, so you need to have 4 parts, which is, this is force, magnitude, x component and y component. So force, magnitude, x component and y component. Okay, so separate into 3. Force is F1. Is there any magnitude for F1? Nope. So just put as a note over there. So okay, which is F1 lah. Just put F1. As component is cos 17 degrees. So cos 17 is going to be 0.9563. And this one going to be sine 17 degree is going to become 0.2924. Okay. So F2, is there any magnitude? Nope. Just put F2 over there. So I'm going to use 20 degrees, so it becomes sine 20. Sine 20 is 0.3420, and this one is negative. Right. Why negative? Okay. Because X negative, Y positive. This one X positive and Y positive. Okay. You also need to be extra careful with the directions. Okay. Okay, next is cos 20. So cos 20 is 0.9397. 0.9397. Okay. So R resulting, you have a magnitude which is 4,200, and the resultant for RX and RY also. This is RX, this is RY, also positive and positive. Okay. So it become, I'm going to use 28 degrees, so it's going to be, okay, so I'm using 28 degree, therefore it's going to be sine 28. Sine 28 is 0.4995. 4995, and cos 28 is become 0.8829. Oh, make sure that your calculator in degree mode, okay, not radian mode. Okay, don't do a careless mistake. There are students actually do that, and the exam itself they actually got like 0 marks, okay, because I forgot to change from radian mode to degree mode. Okay, once you're done with this, okay, like before, you need to find the net force X and the net force Y. Okay, so it's going to be like this. Okay, net force S and net force Y. Because you need to understand, before this I put as a F1S plus F2S equals to RX. Okay, F1Y plus F2Y equals to RY. Positive or negative is depends on your component. Okay, so you are going to do like this, and then you are going to simultaneous or substitution or matrices for you to find the F1 and F2. Okay, please don't use calculator, okay, because this is going to be counting as your mark. So show your working step, because that's the reason why you need to learn calculus, maths. Okay, you need to show your working step. Okay, don't use calculator. Okay, don't use calculator for you to use the simultaneous part. Okay. Okay, so I'm going to rewrite again. Okay, so force F1. Okay, I'm going to use all the I'm going to grouping the F1S first, the S dulu, the S component. So F1, ayo. Okay, 0.9563 F1 here and here minus 0.3420 F2. Okay, angle multiply with the magnitude, angle with the magnitude, even though there's no magnitude, just put F1 and F2 equals to what? This one, which is 0.4695 multiplied by 4200. Okay, and then same goes to you grouping the Y component. 0.2924 F1 plus, okay, double check, make sure that the direction is correct, plus this is also plus 0.9397 F2 equals to 0.88 multiplied by angle. First equation, second equations. Yeah. you'll do the simultaneous. Okay, even okay, yes, okay. I like to use substitution, and I like to use simultaneous. Yeah, because I think it's pretty easy, but you can actually use substitution or matrices. There are actually the students who use matrices. Okay, so you actually use any kind of method, but please don't use simultaneous in your calculator. Okay, so how I'm doing my simultaneous part. Okay, because basically here the number is totally is different, so you can actually just minus like that. Same goes as this one, same goes as this one. So you need to find one thing that you need to make it same, because you are going to find it the same thing, and then you minus it, make it 0, and then you are going to find the f2. Okay, like that. Okay, I don't know how to explain in the maths way, so I'm going to explain in the engineering way. Okay, so for the next part is I'm going to multiply this one with this one, this one with this one, and this one with this one. Okay, so I'm going to get, okay, I'm going to make it fast here. So I'm going to, this one you are going to get 1972, this one you are going to get 3708. Okay, let's proceed with the simultaneous. This is how I'm doing my calculations, so you can actually follow that, or you can, if you want to change, you can actually do that. Okay, so sorry, I think I wrong. Okay, it's better for me to multiply no, wait, this one with this one, 0.953 with this one multiply with this one, and this one multiply with this one. Okay, because I want to make sure that there's one number that's going to be the same, and then I'm going to like deduct it, and then I'm going to find one of the unknown, f1 or f2. Okay, so if I multiply like the green one I mentioned you before, so I'm going to get here is 0.29, no, sorry, I'm going to get 0.2796 f1 minus 0.100 f2 equals to 576.6. Okay, and the next one I'm going to multiply. Okay, I'm going to multiply is here to here, this one to here, and this one to here. Okay, please just ignore the red line here, this is wrong. Okay, actually basically the same thing. Okay, so I'm going to get the next one is 0.2796 f1 plus 0.8986 f2, and then I'm going to get, this one is going to be 546. Okay, so this is the new equations after you multiply, because you want to make it simultaneous. So here you can actually see that this one already the same thing, so you can just reduce the unknown, and then you're going to find the f2. Okay, so this one I'm going to put negative here, so you're going to get, here is this one cancel out, you're going to get negative 0.9986 f2 negative 2969.4. so f2 is basically, you're going to get, the answer is 2974 Newton. Okay, show the calculation, show the workings that this is marks. Okay, the next one is find the f1. So here you need to put it back into the original one, don't put it back here. Okay, put at the original one. You can choose 1 or 2 anytime. Okay, so I've choose the first equation, so I'm going to get 0.9563 f1, f1 I didn't know yet, minus 0.3420 2974 f2, and then this is 1972. So I'm going to get your f1 is 3126 Newton. Okay, please put the units and make sure that you underline your answer. Okay, so this is the way that you can actually use for you to solve missing magnitude of F1 and F2. Okay, so here this is all marks. Okay, that's the reason why I mentioned before you can use the calculator for you to use the simultaneous. I know there's a easiest method. This one is like 2 or 3 marks. Okay, 2 or 3 marks or 2 marks. Okay, so okay, basically the steps that you can actually ignore, oh no, the steps that you can actually skip is this one. Okay, if you already like understand, you don't have to do the table. You can just directly put it here. Okay, so this one is marked. So for you find the F2 is marked, and then you find the F1 is marked. So this is going to be your working step lah. Okay, you can use substitution. Okay, or you can use simultaneous. You can use matrices. Okay, but please be extra alert when it comes you use substitutions. It's quite easy for you to do a careless mistake, so be extra careful. I'm not discouraging you for you to use the substitution, but I can see that there's a lot of students when you use substitution, they're quite confused. So when you're confused, they're going to lose a lot of marks because careless mistake. So be extra careful. Okay, so and then the things that I need to highlight here is make sure that before you start your calculation, if example you find the questions to be like this. Okay, example this, you need to find the missing forces or you need to find the resultant. Okay, here and here, example. Okay, example you have force that actually, example this is 5,000 pound force and this is 320 pound force with the angle of 55 and this angle is 35. Okay, before you start calculation, please make sure that the arrow should pointed upward. This one should be upward. This one also should be upward. Okay, so draw it again, redraw, because what happened is the direction is going to be changed. The negative and positive over there going to be changed. So draw it again. Okay, again. So this one here outward here. Okay, so it's going to be 55 degree and this is 320 lbf pound force, and this one should be outward. It's like it should be pointed outwards. Okay, so this one going to be 5,000 lbf with the angle of 35 degree. Then you start the calculations. Okay, so be extra careful, make sure that your angle always pointed upward from the point, from the axis point. Okay, got it? Okay, once you understand with this thing, please do the extra questions at the back. This question, okay, these questions, and also this question. Okay, so I give you two different questions, which is the one, okay, so the one before is the find the magnitude, and this one you need to find the missing forces and F1 and F2. Okay, so if you have any questions, feel free to ask, and I'm going to give it to you the answer in online teaching. Okay, thank you very much, and I see you again in part 2. Bye bye.